In this video, we're going to go through some examples of taking the derivative of functions involving a natural log. They'll either use the quotient rule, the product rule, or the chain rule in addition. So a, our function is x squared ln of x. So when we go to calculate h prime of x, the overall structure is a product, so it'll be a product rule. So we hold one part constant, x squared, times the derivative of the other part. Derivative of ln of x is 1 over x, plus ln of x times the derivative of the first part, which is 2x. A lot of times there's not going to be a ton of simplifying we can do, but we can do some canceling here. X squared times 1 over x is just x, plus 2x ln of x. And a lot of times we'll factor that x out, so x times 1 plus 2 ln of x. That's about as simplified as we can get. Let's go on to b. P of t equals ln of t over e to the t plus 1. So when we go to find p prime of t, the overall structure is going to be quotient rule, because we have a quotient. And so it's going to be the denominator, e to the t plus 1 times the derivative of the numerator, which is 1 over t, minus ln of t times the derivative of the denominator, which is just e to the t, because it's e to the t plus 0, all over e to the t plus 1 squared. There's not going to be much simplifying at all that we can do in this one, so we'll just go ahead and leave it as is. A lot of times we can factor out the e to the t, but because of this plus 1, we're not going to be able to. So that's about as far as we can go. So, next one. S of y equals natural log of the cosine of y plus 2. So there's something more than just x or y in the natural log. This is a chain rule. This here, this cosine of y plus 2, that's our inside function. That makes the ln our outside function. So s prime of y, remember what a natural log does. The derivative of a natural log is just 1 over x, basically 1 over whatever you take in the natural log of. So it's going to be 1 over, now leave the inside alone, cosine of y plus 2 times the derivative of the inside. So times the derivative of cosine, which is negative sine of y, and the derivative of 2 is 0. And we might go ahead and write that on top. So we have negative sine of y over cosine of y plus 2. And there's our derivative. Let's do a couple more that I have written here on the other side. Tangent of ln of x. So here we have another chain rule with the ln of x being the inside function, tangent being the outside function. So in finding z prime of x, we do the derivative of the outside function. Derivative of tangent is secant squared. Leave the inside alone, ln of x, times the derivative of the inside function, which is 1 over x. And we're done. Let's give this function here a name. That's m of z, let's say, equals ln of the ln of z. This one may look scary at first. Again, just follow your derivative rules and you'll be fine. First thing we want to recognize here is that it is a composition, which means chain rule. Inside function, outside function. So the derivative of a natural log is 1 over whatever we're taking the natural log of. So 1 over ln of z times the derivative with respect to z of the inside function, so that's the other ln of z. So we have 1 over ln of z times derivative of ln of z is 1 over z. And we might go ahead and write this one as 1 over z ln of z. Okay, so you need to have your basic derivative rules down, and that will make it a lot easier as you go to do these product, quotient, and chain rules.